Hello, sixth grade students. This is Mr. Kraft coming to you from my room at Cal. The last few days we've been talking about changing fractions into decimals. Now I want to talk about the opposite. I want to talk about changing decimals to fractions. And this is actually easier than it is to change a fraction to a decimal. The only part that might be a little bit hard, I don't even want to say hard, that might make you think a little bit, is simplifying it. But we'll get to that in a minute. So if you have a decimal, like 345.345, I want to remind you that the first place after the decimal is the tenths place. And then the second is the hundredths. And let me make that look better. And then the third place, I should say, there is no last place, it goes on forever. But the last that we would be likely to use is the thousandths place. So tenths, hundredths, thousandths, and so forth. And we're not going to go past the thousandths ourselves. Okay, and I referred to this in the last video I made, I think, but this is also where the way we read this kind of makes a difference. The way that probably most Americans would read this number, they'd say 0.345. But really, it's probably more accurate to read it as 45 rather, I'm sorry, 45 thousandths. Because I think if we read decimals like that more often, we would understand better what we're talking about, and we would automatically know what it is that it is as a fraction. So you need to know your place value, tenths, hundredths, thousandths, and then all you do then, you draw your fraction, and whatever your last place is goes on the bottom. So in this case, the last position, you have tenths, hundredths, thousandths. So 1,000 goes on the bottom, and then that goes on the top. You drop the zero, the filler zero. You don't use it. You don't use the decimal. 345 over 1,000. Now, the one thing you have to do in cases like this, when do you reduce? When do you reduce a fraction to lowest terms? It's a trick question because the answer is always. Always, always, always reduce to lowest terms. So this ends in a 5. This ends in a 0, so they're both divisible by 5. 5 goes into 1,000 200 times. If you could not see that, you can always divide it out off to the side. 345. Well, 5 times 6 is 30. 5 times 9 is 45. Well, 69 can be divided by itself and 1, of course. It can be divided by 3, because if you add the digits, that's how you find out divisibility by 3. 6 plus 9 equals 15. So 3 will go into it. However, 3 will not go into 200. 2 plus 0 plus 0. Not that you need me to show you this, because it's kind of obvious. So, buzz, 3 does not go into it. 4 doesn't work. No even number works. This is odd, so no even number works. 7 doesn't work. 9 doesn't work. So I would say that looks to me like it is in lowest terms, so you would stop. That's all. Okay. So just to use some examples, say you have 0.7, 0.28, 0.15, 0.8, 0.111, 0.125. So all of these are very easy. So this here, the last place, is the tenths place. So 7 over 10, the last place is what goes in the denominator. This goes in the numerator. 7/10 cannot be reduced, so you're good. Same way here, this would be 8/10, but that can be reduced. 2 goes into 8 4 times, and 2 goes into 10 5 times. This would get you points taken off, because that is not as simple as it could be. You always need to reduce it. Here, the last place is the hundredths place, tenths hundredths, 28 over 100. Well, 4 will go into both of these. 4 goes into 28 7 times. 4 goes into 100 25 times. So that reduces that. And we have talked about the rules of divisibility. I'm not going to go back into that here. I might put another video up for you just for reference. But 4 goes into 28, 4 goes into 100. So this is your final answer there. 15 over 100. Once you see the pattern, you don't have to keep saying tenths, hundredths, thousands. You see one digit is tenths. 2 digits are hundredths. 3 digits are thousands. Once you see the pattern, there's not much work to it. Then 15 is divisible by 5. 5 into 15 goes 3 times. 5 into 100 goes 20. So that is what you get from that. 111, 3 digits. I just now said that'd be the thousandths. 111 is divisible by 3 because the digits 1 plus 1 plus 1 is 3. 3 will not go into 1,000. That's as simple as you can get it. You stop there. Last, 125 over 1,000. It's clear that 25 will go into this, and I'll show you an easy way to do it. 125 equals 100 plus 25. So that's like $1, 4 quarters, plus another quarter is 5 quarters. That's how many times 25 goes into it. 1,000 is like $10. 4 quarters goes into each. So that's 40 quarters. Okay. And that can reduce even for 1/8. So 5 goes into itself once, 5 goes into 840. And just to prove that that would work, you would see that 8 times 125, 8 times 5 is 40, 8 times 2 is 16, plus 4 is 20, carry the 2, 8 times 1 is 8, 9, 10. So see, that works out. So that is your final answer here. All right. That, I think, covers everything sufficiently. I'm going to leave it at that. I hope everything is going well for you, and I'll talk to you the next time. Bye.